Hello friends, welcome to my YouTube channel Genetics. In this video, we'll discuss about embedding. Embedding is the third most important component of RAG architecture, which I have shown you multiple times. Okay, so let's get started. So it's the definition of it. An embedding is a numerical representation of text. Text means sentence, paragraph, or document as a vector in high dimension space. Okay, and this space is 382 3072 dimension. So this dimension means size of vector. Okay, that means array of number, right? So most of the embedding model lies between this number. Okay, and this number depends on the architecture of that model. So all the low level models gives low dimension, and high level model gives high dimension. So low level dimension means low accuracy, and high level dimension means high accuracy. Okay, just remember. I give you one example how this dimension physically expressed. Okay, so suppose I have a text. I live in India. Suppose this is my chunk. This is my text. I have to embed this chunk. Okay. Now, if I'm using any model that gives the 384 dimension, okay, then what happened? Then my text will be represented as like this. Suppose 0.12, 0.42, 0.23, like this up to 384. Up to 384. This would be the dimension of this chunk if I use any model that gives 384 dimension. Now suppose I am using any model that gives 3072 dimension. Chat OpenAI, Google, they provide 3072 dimension. Okay. So in that case, if I embed this my chunk, then it will be converted like this: 0.12. For example, I'm giving you 0.41, 0.72, and dot up to 3072 dimension. Up to it goes up to 3072. Okay, because this model gives 3072 dimension. So this is how our chunks got converted in vector. Okay, so remember one more thing. In our document, when we are converting all our chunks into embedded model, then remember all our chunks, all chunks will have the same dimension. Okay, just remember, irrespective of number of words, number of characters, whatever chunks we have, all the chunks we have the same dimension. Just remember. Okay, so if in our document we have 100 chunks, then all 100 chunks will have the same dimension. That is, if 34 or 372, whatever it is. Okay, all chunks will have the same dimension, right? So this is dimension. So the idea is similar meaning similar vector. Okay, example is car and automobile vectors close together, car banana vectors far apart. That means, suppose let me erase it. Suppose car represented as 0.21, 0.42, 0.63, 0.84. Okay. Now, automobile. When we embedded this automobile, then it will be like this: 0.23, 0.45, 0.59, 0.80, like this. And when we will embed this banana, then it will be like 0.84, 0.72, 0.93, 0.10, like this. Because see, car and automobile lies in the same community, right? Same community. That's why they both represent the almost similar vector or nearest vector. Okay, but banana is completely in different segment, right? So whenever you compare car and automobile, then you will get a similar vector. But if you compare car and banana, then you will not get any kind of similar vector, right? You will not get. That is why car and automobile have the cosine similarity, and in the backend, this operation has performed. Okay, that is why it is written here: car automobile vectors close together and car banana vectors far apart. Okay, so I hope you understand. So next is, why do we use embeddings? Okay, so embeddings are the bridge between natural language and machine understanding. They allow models to measure semantic similarity instead of relying on exact word, right? So we have already learned, using embedding, we just convert our natural language to machine understanding language, right? And in the backend, the semantic similarity operation has performed. That's why we got the related vectors to get our answer. Okay, this is why we need to use embeddings, right? The key uses is semantic search, that I have already told you. Find relevant text even if exact words don't match. Okay. RAG, retrieval augmentation generation, retrieve contextually relevant chunks for LLM. Same thing. Clustering and clarification, I've told you. Group similar text together. Duplication or paraphrase detection, identity near duplicate content. And recommendation is suggest item based on semantic similarity. Okay, so these are the use cases where that is why we need to use embeddings. So let's jump to the practical part and see. Okay guys, so I have opened my VS Code. So this is our 8th class. So I'm creating a new file. That is 08 embeddings .ipynb. Okay. Now this is my kernel. Now I hope. Okay, now it's working. Okay. Okay guys, see, in this video I'm going to use Google embedding model. Okay, Google Gemini embedding model. So everybody you can use any kind of embedding model, OpenAI, Hugging Face, anything. But for this video, I'm using Google Gemini embedding model. So if you want to use this Google embedding model, then just go to Google AI Studio and create your API keys. Okay, and you save your API key in .env folder, .env file. Okay, so please everybody do this. So I have already set my API key in my .env file. So to use this embedding model, we have to install one dependency. That is LangChain _Google _Gen AI. So you have to install this library. Okay, so let us install. Well, Python, let me check my Python. Okay, it is running. Now let's install it. Okay, pip install -r requirements.txt. Okay, now our Google Gen AI embedding model gets installing. Okay, so wait for a minute. Now it has been installed. Okay, now let's get back to our file. Now let's delete it, and I'm writing Google embedding model. Okay, now to import our Google embedding, we have to use from LangChain Google Gen AI import Google Generative AI embedding. Okay, now we have to import our .env from .env import load env to load our environment variable. Okay, so let's load .env. Now it's done. Now we need to initialize our embedding model. Okay, so embed equal to embedding, and within this we have to mention our model. So we will use model Gemini embedding 01001. This is the model. Okay, now we will use this embedding model. So now what we have to do, we have to call our embed dot. See, there's two options: embed documents, embed query. Whenever we will pass our any query directly in the embedding model, then we have to use embed query. And whenever we have to send our total document as a chunk or as a text, list of text, then we have to use embed documents. Okay, so first we see embed query. Okay, and I'm passing one text. I live in India. Okay, now let me print. Okay, let me do one thing. First, run this one, and let's see. See, this is the dimension. This is the vector representation of I live in India. Now, if you want to see the length of this dimension, then do one thing. I am putting this into one vector variable. Okay. Now, print length of this vector. Okay, and if you want to see the this basically gives the number of chunks. Okay, and if you want to see the dimension, then we have to use length of the first chunk. Okay, first chunk, then you can see everything. Now see. Okay, just a minute. Okay, sorry, as this is our single query, so it doesn't have any list of chunks. Okay, that is why it is showing error. Now see, the dimension of our query is 3072. So whatever query you will mention over here, all will have the same dimension 3072, because this Google Gemini embedding model gives 3072. So if we pass here anything, I want to have my dinner, that also gives the same size of dimension. Okay, this is the main funda. Now let's do one thing. Now we are copying the same thing. Okay, now let's copy everything. Now we are passing, instead of a query, we are passing a list of text. Okay, suppose text, a list of text, and suppose one is I live in India. Okay, and another is I am a data scientist. Okay, these two list of text I am passing. Okay, now same thing like this. Okay, embed dot, this time as we are passing our list of text, that's why we have to use embedding documents. Okay, and within this we have to pass our text, this text, list of our text. Okay, now see, what is it? Now see, there are two chunks. Okay, so this is the first chunk. This starts from here and it goes up to 3072. Okay, now if you scroll down here, you will find somewhere it gets ended. See, here it is just ended, the first one, and the second one has been start from here to here. So both chunks have the same dimension 3072. Okay, Now check it once. Now in the same way, okay. I have to copy this line, okay. Okay, and now we have a list of text that then we can find the length of vector, the first one. Okay, now let's see. Okay, there is spelling mistake. Okay, I have written it twice. Sorry. Now see, the length of the chunk is 2 because we have passed two sentence, right? So our chunk size is 2 and our dimension of all the chunks is 3:2. As we have passed 0, that means the first one, I live in India, that is 3072. But if you pass over here the 1, that means the second one, I am a scientist. If I pass this one, then also it gives the same result. See, 3072. So I told you na, all the chunks in our document will have the same size of dimension. Okay, so always remember this one. So now we do one thing. We have a we will embed our on of our PDF document. Okay, let's do it. Embed PDF file. Okay. Because in our real-time scenario, we have to always embed our file, all the files, right? So let's start. Now again, I'm copying everything. These are the common things. Okay. Okay. And to load our document, we have to use our text loader, right? So from LangChain dot underscore community dot document loaders import PDF loader. Okay, PDF loader. Now everything is mentioned over here. Now I have to mention my file path. Now I'm using one PDF I have, that is air pollution PDF. Okay, copy edit path. I'll put it over here. Right now we have to use our loader. Right. And within this, we have to take pass our path. I hope you are understanding because I have already shown all this example in our previous class, right? So I have loaded my path and now loader dot, we have to call load function, right? And this becomes our docs. Okay. Now, once we got our docs, then what we have to do? We have to split our text, right? So again, I'm trying to give you the step-by-step example. Okay. So now for text splitter, I have to import from LangChain dot text splitter import recursive character text splitter, right? So again, we have to define this one. Splitter equal to recursive character text splitter, and we are mentioning chunk size as 500 and chunk overlap equal to 30, right? Now what we have to do? We have to split our text, that is splitter dot split documents, right? and within this we have to pass our docs, right? And we are saving it in a variable that is chunks. Okay. Now guys, as in our embedding model, we have to send a list of text, right? List of document. That is why, but in whenever we got our chunks using this recursive text editor, then you might remember there once we got the output, then there is two component. One is page content and one is metadata, right? So we want only page content, and that content I have to send in my embedding model to get vectorized, right? So that is why we have to extract our page content only. Okay. So what we have to do? Suppose text, we are writing text content equal to, we have to write run a loop. So for chunk in chunks, okay, and from here we have to increase the page content. So page content of what? This chunk dot page content. Okay, and we have to give a square bracket over here. Now see, so what is happening? We got the chunks. So here we have multiple chunk, right? So using a for loop, we are extracting all the chunk in single. Okay. So from chunks we are extracting chunk, and from this single chunk we are extracting page content. So basically we are extracting all the page content of all the chunks one by one. Okay. Now we have to send this text content to our embedding model to get vectorized. Okay. So now what we have to do? We have to do the same thing, that is embed dot embed documents, and within this we have to pass our text content, right? Now see, now what is the problem? Now we got the entire vectorization. Now see with the size and chunk size. Okay, print chunk size, length of, okay, let me put a variable, okay, and length of vector, right? This is the chunk size and dimension, chunk dimension. Okay, chunk dimension is length of vector, and we can mention in any number. Okay, now let's see. Now see, our document got splitted into 23 chunks, and all chunks have the same dimension that 3:2. If I provide 23, we have 23 chunks. So if I provide 15, that will be the same. See, 3:7 dimension. So this document got split into 23 chunks, and all chunks have the 3:7 dimension. Okay, now this is how we embed all our documents before sending it to the vector store. So what happened? Now we have vectorized our document. Now we'll send this vector to our vector database to store. So that will be our next chapter. We'll see everything about vector database, everything. Okay. So in this video, we have covered our embedding models. So let it push in GitHub. Git and then git commit -m. What should I write? Okay, embed the embedding added. Okay, now git push origin main. Now guys, I have pushed all the documents in my GitHub. So I will give this GitHub link in my description box. So whenever you require, you can check over there and you can download the codes for your practice. Okay. So guys, by doing this, we are ending our this session. Okay. So guys, one more request: if you like my videos, please do like and share my videos. And if you've not yet subscribed, please subscribe my channels and support me. Okay. Thank you. Thank you so much.